is operating leverage? It is something that magnifies firm-specific cash flow risk, which we will see later. And the next question is, does operating leverage increase the risk? The answer is not necessarily. So here, let's start with the concept of operating leverage. It is an important idea in accounting, economics, and finance that measures how much a firm's production relies on fixed production costs. But we may think that fixed costs are quite difficult to define, as all costs are quite variable. They can be adjusted by the firm in the very long run. Then an equivalent interpretation of operating leverage is that if a firm has high operating leverage, then given a small change in its sales, the operating profit is going to be magnified. That amplification effect from operating leverage. And it is also because of this channel that people use operating leverage to explain the value premium. So the idea is that those value firms with high book-to-market ratio, they earn a higher return because they are riskier. They have more fixed costs relative to their revenue, so that they have high operating leverage, and people tend to think that they have high risk. And actually also the high operating leverage would amplify the cash flow volatility for those value firms. But again, an empirical challenge is that it is difficult to measure operating leverage empirically. Otherwise, in the very practical sense, we form some trading strategies based on operating leverage instead of book-to-market ratio, like we have seen in practice and in paper. So how to accurately measure operating leverage? This is what we have done in this paper. So we propose two new measures of operating leverage. The first is an out-of-sample neural network-based measure. So it is the best measure to capture that cash flow magnifying effect. So it is the best to capture this in particular, that is the operating profits sensitivity to gross profits. And then we also propose a flow-based measure from a production-based model. So that is used as an input for the neural network estimation as well. And despite it's simple, it still captures some sort of magnifying effect. And then we find that it is important to notice that the relation between operating leverage and the risk premium is hump-shaped, not negative. So as operating leverage increases, the risk premium would first increase, but as the operating leverage further increases, the risk premium would drop. So with those two new measures of operating leverage, we find that the value premium is unlikely to be driven by the operating leverage we will see later. So we develop a production.
Can you explain the first point on the best measure capturing operating profits sensitivity?
To gross profit.
That will be the best measure for operation leverage?
Yes, so you can think that operating leverage has the amplification effect for cash flows. So if a firm has high operating leverage, then its operating profits would grow faster than its sales or gross profit. And that is the very basis we use to operate.
It's the expense side, not the income side.
Right. That's the two sides of the operating leverage. So if we look at the costs, then operating leverage indeed measures how much a firm allocates fixed costs to production. But fixed costs would be quite difficult to measure. And we will see that, in fact, the second measure, it is the cash flow ratios of the fixed costs to gross profit. So the first measure is based on the amplification effect, and the second measure is more like we literally interpret the operating leverage on fixed costs to other production.
Can you do it across different industries?
The same industry. Across all firms, they are the same definition. We will see later in a few slides. So here, the very basic idea is that we interpret operating leverage into ways, two equivalent ways. One is the amplification effect, the other is the fixed production costs. We try to find some measure that can best proxy the fixed production costs, which we will see in a few slides. But thank you. So what motivates that fixed costs and also the non-positive relation between operating leverage and the risk premium? We use a production-based model with both fixed costs and variable costs to better understand the operating leverage. And also, our analysis can explain the idiosyncratic volatility premium. So let me start with the empirical. So the data we use is very standard. So we use CRISP for stock return data, and we use CompuStat for accounting data. And existing literature has different measurements for operating leverage. So we can see that for the first, third, and fourth, they have different kinds of selling, general, and administrative expenses in the numerator. And their denominators are different measures of assets, total assets, or market value of assets. In fact, this SG&A expenses can be thought of as a form of fixed costs. But as some of you might know that, in fact, different industries may have different classification of whether those production wage, workers' wage are in the SG&A or whether some other wages are in SG&A. But nevertheless, we can somehow think of this as a sort of a proxy for the fixed cost. And in fact, a strange one or a different one is the second by Ferry and Jones. It is the ratio of fixed assets to total assets. So our first flow-based measure of operating leverage is the ratio of fixed costs to gross profit, and it is the same for all firms in the industry. It is simple to construct, and later we will see it is motivated by our production-based model. And it quantifies the proportion of gross profit allocated to fixed costs. Then what's important is the second measure, the neural network-based measure. So we try to estimate something here, the coefficient that can best capture the operating profit sensitivity induced by gross profit. So here we throw something into this estimation equation and try to somehow minimize the error here. So those characteristics we use to capture this amplification effect include the market beta from CAPM, which can be thought of as a proxy for the systematic risk, idiosyncratic volatility, which can be a proxy for the idiosyncratic risk, book-to-market ratio, since people tend to think that value firms, those high book-to-market ratio firms, have high operating leverage. And then we have gross profitability and operating profitability. So we tend to think that unprofitable firms tend to have high operating leverage. And also 5 different measures of operating leverage in literature. So the estimate of our operating leverage is each year we train the neural network. We use cross-validation to select some hyperparameters. And once the model is trained for that particular year, we can apply that neural network to those most updated characteristics. So we get monthly out-of-sample estimates for operating leverage generated using the trained model. So here is a validation of our measure of operating leverage. So to test that notion of operating leverage magnifying changes in operating profit induced by changes in gross profit, we conduct a panel regression where the left-hand side variable, I haven't written here, but it's the growth rates for operating profits, and the right-hand side variables are the growth rate of gross profit and the interaction of this gross profit growth rate and the different measures of operating leverage. So here we are interested in the coefficient in front of this interaction term. The larger that coefficient, the better this measure captures the operating leverage effect, that magnifying effect. And all those measures have been standardized before we run the regression. So here, let's look at the second specification. So it means that a 1 standard deviation increase in our neural network-based measure of operating leverage is associated with 1.38 standard deviations increase in this elasticity, in the magnifying effect. And this is the highest among all other measures in literature. In the meantime, we can see that our flow-based measure is still 0.85. It is larger than other existing measures in literature. So overall, we see in univariate regressions, our neural network-based measure is the best to capture this magnifying effect. And this flow-based measure is an organic measure, but again, it is the best among all other counting measures to do so. And also, I want to highlight here in column 8, 9, and column 10, we run a horse race regression where we include all those measures of operating leverage. And we find that, in fact, this neural network can kill all other organic measures, even include, maybe marginally include our flow-based measure. But again, it is the best to capture this effect, and it dominates all other existing measures. And also, we have done a bunch of robustness checks. So here in the top panel, we change a little bit of that neural network estimation. So we either use a broader range of hyperparameters to somehow be more robust, or we use more complicated networks, such as a wider one or a deeper one. Also, we tried more predictors, and also we tried different boosting methods. And we can see that if we somehow complicate the estimation method a little bit, the parameters are more or less around our benchmark estimate at 1.38. And in the bottom panel, we use some alternative machine learning techniques, including rich, lasso, random Fourier transformation, and an ensemble of all those measures. And in fact, this ensemble measure is the best out of all those existing measures. But again, our neural network measure is the most robust, and the best one is not like a significant increase in performance. So we still use this neural network estimate as our benchmark measure for operating leverage. Now that we have seen the measures, and then let's investigate the relation between operating leverage and the risk premium. So we form portfolios based on operating leverage. Then we look at the excess return. So we can see that as the operating leverage increases from the lowest to the fourth quintile, the excess return first increases. And this fourth quintile has the highest excess return, and from the fourth to the highest quintile, the excess return significantly drops for both the neural network measure and the flow-based measure. And we can see there is, in fact, a hump-shape relation between operating leverage and the risk return, where the hump, the highest excess return, occurs at the fourth quintile. And the high minus the fifth return minus the fourth return is significantly negative. But in the meantime, if we look at some other characteristics, then the higher the operating leverage, the higher the market beta, CAPM beta, and also the market beta in Fama-French three-factor regression, the SMB beta, but it is not necessarily magnifying the HML beta. So in other words, the operating leverage, it magnifies the CAPM beta and some other systematic risks, but it does not magnify all systematic risk. And the relation between operating leverage and the return is not positive monotone, but a hump-shaped relation. And also, this is a robustness check for different measures of operating leverage estimated using some other slightly different machine learning techniques. So we can see overall, there does not exist a positive relation between operating leverage and risk premium, but we see quite a robust negative or even hump-shaped relation between operating leverage and stock return. And also, we have sort portfolios, sort stocks based on their historical operating leverage. And again, this lack of positive premium persists over past 3 years. So over time, we do not see higher operating leverage, magnifying risk. And then let's look at the relation between operating leverage and the value premium and see if the operating leverage can explain the value premium. So here what we do is we first replicate this value premium in our updated sample from 1979 to 2022, and we see this value premium is not very significant. But in our internet appendix, we have used a longer sample, and then the value premium is more significant. But what's more important is next. We form portfolios on book to market conditional on operating leverage, and we see this conditional book to market, this conditional value premium is more significant compared to this unconditional one. And this suggests that the operating leverage is unlikely to be the main driving force for the value premium. For otherwise, we will see this number, this conditional premium to be zero, but we indeed see an increase. And in fact, in a longer sample where this benchmark book to market premium is significant, then the conditional value premium is even more significant. And our conclusion is that the operating leverage is unlikely to be the primary driving force of the value premium. So here, let's do a very brief recap. The idea is that operating leverage, the neural network measure is the best to capture that magnifying effect, and the flow-based measure is very easy to construct one, but again, it captures a large amount of that elasticity. In the meantime, operating leverage does not increase this risk premium monotonically, and it's unlikely to explain the value premium. And then we are going to see what's going on there. We use a production-based model to study the effect of variable costs and fixed costs. So in fact, in existing studies, we tend to, especially those in theoretical paper, we tend to assume that all costs are fixed. And that is because fixed costs are simple to measure. We just subtract a constant from the profit. But if we look into data, then we see that only a small part of revenue, 6% of revenue, is fixed cost, while more than 2/3 of revenue is variable. Those variable costs are more cyclical than revenue. So you can think that in, for example, if your salary is higher than 10,000 million, you pay more than 60% of your salary as your mortgage or your rent. But if your salary is less than 20,000 per year, then you pay a very small amount of your salary as your rent. And in that case, the rent payment is not like quite a big hit on your financially, but it's more like a risk reduction effect, a hedging effect. And same is like the variable costs for firms to produce. So during bad times, their their variable costs would reduce more than their revenue. So overall, their gross profit is less risky compared to revenue. And this is an important channel to generate the gross profitability premium. So the idea is that more profitable firms, they have less variable costs compared to revenue, so that the risk reduction effect from variable costs is weaker among those more profitable firms. This makes those firms with high profitability riskier and earn a higher return. And so far we see that fixed costs are quite rigid, and they may be magnifying risk, while variable costs are more volatile and they tend to reduce the risk. So what would be the effect of variable costs and fixed costs? So we use a production model with both fixed inputs and variable inputs to study the effect. So let's skip this model and look into the implications. So first, if we want to see the effect of variable costs reducing the riskiness, then we find that as long as those variable costs are there and some technical conditions are held, then variable cost always reduces firms' risk exposure. And then if we want to look at the effect of fixed costs, so we can see that sometimes when gross margin is high, then fixed cost would raise the risk exposure. That is the conventional operating leverage effect. And when gross margin is sufficiently low for those extremely unprofitable firms, then fixed cost would reduce the risk exposure. That is, the fixed cost would magnify the risk reduction effect from variable costs. And in fact, in us solving this whole problem, the expressions for gross margin and operating leverage emerge naturally from the first order conditions. So here, from the model, operating leverage is defined as the ratio of fixed costs to gross profit. And then we can see the firm's overall exposure, the systematic risk measured by beta, and it is similar to the nonlinear effect of the fixed cost. So if we look at this figure, we can see that the higher the operating leverage in this yellow area when gross profitability is high, 0.6, then the higher the operating leverage, the higher the beta. But when gross profitability is very low in those blue areas, then the higher the operating leverage, the lower the beta. So operating leverage, the beta systematic risk depends on gross profitability. But in the meantime, the higher the the higher the gross profitability, the higher the beta. And this positive relation is strongest when operating leverage is high along this line. So we can test this in data. So first we conduct the conditional sort, first on operating leverage, then on gross profitability. So we see that this gross profitability premium is higher among those higher operating leverage stocks, both for neural network and flow-based measure of operating leverage. But in the meantime, if we sort for stocks on operating leverage, then among those unprofitable firms, the higher the operating leverage, the lower the excess return. So this is consistent with the beta figure we have just seen. So we find that using this production model, operating leverage effect depends on gross profitability, and that explains why we do not see a positive relation between operating leverage and the risk premium. That is because for those very highly operating leveraged firms, they have a lot of unprofitable firms, so that the variable cost would reduce the risk for those high operating leverage firms. And our model can also provide an explanation for the idiosyncratic volatility premium documented in literature. So we see that higher idiosyncratic volatility firms have low excess return. This is significant. But in the meantime, they have higher operating leverage and very low gross profitability. So the idea is that we estimate operating leverage based on that magnifying effect. So by definition, those high operating leverage firms, they have higher cash flow risk. But they are also unprofitable firms. So the high operating leverage would magnify those idiosyncratic cash flow risk as we estimate that, but those low profitability would reduce the exposure for the systematic risk as we have seen in the beta figure, that 3D complicated figure. So it is the separation between the operating leverage magnifying the firm-specific risk and this operating hedge from variable costs that reduces the aggregate risk that gives rise to this negative idiosyncratic volatility premium. So to test this mechanism, we project this idiosyncratic volatility factor onto the operating leverage factor and the gross profitability factor. And we can see that when both operating leverage factor and the gross profitability factors are included, the the idiosyncratic volatility premium is reduced to a very large extent to an insignificant level. And this is a noteworthy result because the idiosyncratic volatility is constructed using stock returns, while both operating leverage and the gross profitability are constructed using accounting data. So now let me conclude. That's all about my paper. So we propose two new measures of operating leverage in this paper. One is the flow-based measure, the other is the neural network-based measure. And the neural network-based measure is the best to capture that magnifying cash flow effect. And we find that with both measures, operating leverage is unlikely to be the main driver for the value premium. We use a production-based model to study the effect of operating leverage when there are variable costs, and we find that the conventional magnifying effect of operating leverage exists only among those high profitability firms. And for firms with sufficiently low profitability, fixed cost would reduce the risk premium. And also we find that operating leverage and operating hedge together can explain the idiosyncratic volatility premium. That's all about my presentation. And do you have any questions?
Can you explain how you estimate the operating leverage with neural networks, please?
Oh, yes, thank you. So this is the timing for that estimation. So each year we train this model once those accounting variables are available. That is at the end of March, the following year. So we try to throw in some characteristics that can capture the operating profit sensitivity induced by gross profit, and those characteristics are available the previous year. And in this estimation, we use 5-fold cross-validation to select some hyperparameters. And once those hyperparameters are selected, we have got this neural network model. And then once this model for this year, T, is available, and then we, let's say, for example, the next available, or maybe one available set of characteristics is in here. And we can apply those previous neural networks to the most recent set of characteristics. And we use 10 past models to reduce those estimation errors. And an operating leverage neural network for September the following year is an out-of sample in the sense that those networks are estimated using completely historical data.
Thank you.
Thank you.
Okay.
Thank you. And I think it's a good time to enjoy the weather outside. Nice.